Hello and welcome to this webinar. Once again here, I'm really happy to have you here to this automate waste recycling with hyperspectral imaging. I'm really glad to have you here. So I am Mathieu Marmion from Specim as an application specialist. And I'm not alone. I'm really happy to have you here in our studio. I'm also with Jörg. So Jörg, please introduce yourself.
Yes, my name is Jörg Schmitz. I'm located in Munich, Germany, and I'm responsible for business development at Specim, and I've been working for 6 years with Specim products.
Great. I'm really glad to have you here with us. I mean, it's wonderful. So here, this webinar actually is going to be in three parts. There is an introduction part that now, like we are talking. Then there is a presentation and also the demonstration. And then finally, there is a Q&A, question and answers. So the Q&A, you will not have the possibility yourself to talk, but you will have the possibility to write for your questions. So when you have a question, please write it down, and then we will read them one after the others. You can also write the questions whilst I'm talking, while we are making the presentation and also the demonstration. It doesn't matter. We will just collect them during the speech. Also, you will see there will be some polls, and it will be good if you could answer those polls, those questions. And yeah, that's how it is. So happy to have you here. I hope we are going to have a good webinar, and then let's go for the presentation. Hello everyone, and welcome to this webinar dedicated about waste sorting with hyperspectral imaging. This webinar actually is not the highlight of the presentation. I mean, this PowerPoint, it is just a side to explain you what it is. So first we go to the agenda. So as a first, I will give an introduction about Specim, who we are, even if most of you already know. Then what is hyperspectral imaging? That's going to be covered in a short nutshell, really because most of you already know what hyperspectral imaging is, and I think you can find more information, for example, on our website. Then we're going to speak about the benefit of hyperspectral imaging in the application within the context of waste sorting. Here we will really explain why this technology is beneficial compared to the other ones. Then we will explain different examples or show some examples of successful application. Some of our customers integrated actually our system successfully for the recycling industry. As you know, we have launched since actually about a year our new hyperspectral platform dedicated for real-time industrial processing application. So we are going to speak about SpecimONE with a live demo, and then where actually you will have more interaction with me and also with all of you, with all of us, is going to be the question and answers. So first, who I am, quickly to speak about who is your host today. I am Mathieu Marmion, working as a lead application specialist at Specim, spectral imaging, for more than 10 years now, and I'm happy to make this presentation for you. Then, about Specim. As you know, the company has been founded in 1995 and is actually a spin-off of VTT. VTT is actually the Finnish National Research Center. There were 3 persons working there who decided to found Specim 27 years ago, thanks to Esko, Timo, and also Jukka. Over those 27 years of existence, Specim has delivered more than 9,000 devices dedicated for the world of hyperspectral imaging. Since 2020, we are actually part of Konica Minolta as a Konica Minolta group, or the big family, and we have also expanded all around the world. So as you can see from the map, we still have the headquarters, which is based in Oulu, Finland, and we also have offices in the United States, Spain, Germany, and China. All right, that was the introduction for Specim, really short, and I will speak as well about hyperspectral imaging and what it is. As I mentioned, this part will be pretty short as you already know what it is, but just as a reminder for those who are not experts. So basically, hyperspectral and hyperspectral camera, especially the one made by Specim, they are line scan devices, and for each pixel of the line, some spectra are recorded. So then, because each material doesn't reflect the light the same way, it is possible to have and to record for each material a spectral signature, which is corresponding a little bit like a fingerprint for each human. So here, with the technology, you have the possibility to identify different types of material based on their color, if you are working with a color camera, or based on their chemical composition, if you are working more with an infrared camera. So once you have made a model to teach what is what, you have the possibility then to export it to samples that you don't know, to make some sorting, to make some sample recognition. And this is actually what you can see on this image on the left-hand side. You can see that with your human eyes, you could see different type of plastics with your type of colors, but you are not necessarily able to identify the material. With a hyperspectral camera, with a statistical model, you have the possibility to identify different type of materials. And here, this is what we are going to use, especially for the recycling application. So the next part of this PowerPoint, of this presentation, will be dedicated to the benefits of hyperspectral imaging in waste sorting. Hyperspectral imaging is the best solution for material identification. Indeed, it can identify different materials based on their chemical composition, because remember, for this type of application, you don't want to sort them necessarily based on the shape, nor based on the color, but based on what they are. And this technology allows you to do these kind of things. You can capture also the whole material stream in a real time with a single scan. Basically, you can have a conveyor belt which has all the material on it, and only at once, only one measure is enough so that all of them can be sorted at once. It is fast, accurate, and reliable. It's much more, how can I say, objective that when you will have people sorting the things manually, you know, every camera, they could see the things the same way, and it is much faster as well, thanks to the new involvement of the hyperspectral technology to finally be able to go to speed. Also, you can have an automate workflows. So that means here you can teach the things, you can have things with automate at the end without all those constraints, for example, with labor. Everything can be done in an automatic way, which is also much more accurate. You can increase the recycling volume and the efficiency because it goes together with the speed, which can be much faster, a conveyor belt, which is fast, and things like this, increasing also the return of investments. It enhances the purity of recycled material as well. That's another point which is important, because here you can really sort material and also examine what is their purity. You can sort them really looking at their composition, not only by just guessing what they are. And then you can decrease the cost and maximize the profit. Why? Because a hyperspectral camera has a cost that you pay once. Of course, there might be some maintenance, but still, after some time, you have your return of investment which is made. And to be able to do that, Specim a few years ago launched the FX cameras, the FX series. Those were the first hyperspectral cameras specifically designed for the industrial machine vision. Here at Specim, we really made an effort to understand the requirement of the industry and to try really, we did our best to make those cameras to fulfill those requirements. And here, as you can see, we have the FX10 and the FX17. Those cameras have been launched, wait a minute, if I recall well, I would say 2016, I think. 2016 for both of them, with few months in between. And since that time, a lot of people have been using them in a really happy way. They are small, fast, and affordable. So in a way that they can be integrated very easily, either in the software, from the software point of view, because they are compliant with most of the standard format, the standard way of communication with the device. And also, mechanically speaking, as you can see, there are many possibilities to mount them on your machine. Also, we paid really attention to the F numbers so that actually the light which is gathered by the camera is really done efficiently, so that actually the customer could use them with a short integration time, fast acquisition rate, and also with a limited, it is relative, but with a still affordable quantity of light in order to use it with a good signal-to-noise ratio. And it's what we are saying, the high signal ratio. For more information, actually, you should go to our website, and here you could see more into details the data sheets. Also, since this one, I would say, is 2019 or 17 maybe, we had the FX50, which this one is between 2.7 and 5.3 micrometers, which is dedicated this time to the thermal infrared and for the black plastic sortings. It could sort also the other ones, but also the black plastic. The FX17 could not do that. All right, So now let's move to where our customer have been implemented in a successful way our camera. The first one, it's about plastics, because you know recycling, it is a lot of things. You have a lot of application. As we will see, there will be fabrics, there will be waste like construction waste. But the first one I would like to speak about, it is about plastics. It is an important one. You know, we have plastics everywhere. At your home appliances, in your car, in all your environment, everything you touch, basically, not everything, but many things are made of plastics. Here we have those cameras, we have the FX17 and also the FX50, which are really suitable for that. Remember, the FX17 can sort the plastic if they are not black. So here you could see on these examples, we have measured different types of plastics like PE, ABS, PVC, PP, and well, all the other ones you can read. No one of them is black. We measured them, and then a model was made in order to assess the sorting. And as you can see here, the sorting was pretty successful. The FX17 is really good for that. Then the FX50 was used for the same type of application, but this time with black plastics as well. And here, as you can see, the sorting performance of the FX50 is remarkable. FX50 can sort the plastic even if they are not black. So here again, you can really see that there is a simultaneous and reliable identification of different types of polymer. Most of those which are used in a daily life can be sorting, like PET, PE, PVC, and so on. And near 100% purity can be achieved with those devices as well. The next application, it's about textile. Textile, you know, we use it, all of us. And on average, it is sad to say, but every cloth is thrown away after the 7th use only. And to make those clothes, it has a cost to the environment. So for example, cotton, like this shirt, grow in some countries where you do not necessarily have a lot of water. And here it has an impact on the environment to grow it. Also, you know, the production is not necessarily at the same place from where it is used. And it is the same for most of the clothes, by the way. Polyester is a kind of plastic, so it means that it could be recycled as well, wool, and so on. So here you could see there was a model which was made, again, to sort different types of fabrics, regardless the coloration, to sort, for example, the synthetic ones from the plant-based fiber ones, from the animal-based fiber ones. And again, here the application was successful with the FX17. So you could turn textile waste into renewable material. Again, you can sort the different type of material from each other to use them either to make new fabrics, make new clothes, or to do something else. And also you can really quantify the amount of natural versus the amount of synthetic fiber in a mixed textile for the blends. And actually this application, textile sorting, is going to be exactly the one I'm going to speak about when we are going to make the demo of SpecimONE. As you can see here, we have different types of fabrics. We have wool, cotton, and also polyester. Another type of application, another application where the technology could be used for like waste recycling, it is for construction waste. We have buildings everywhere, and sometimes when they start to get old, you need to destroy them. We do that in Oulu all the time. City center, I have seen many times like those buildings destroyed. But then you have a lot of things in there. You have some concrete, you have some wood, you have some tiles, some paper, some cardboard, some plastic, some rubbers, a lot of different types of materials. And here again, FX10 combined actually with the FX17 offer the capability of sorting all of those at the same time. It could be used for combusting material or some new valorization. So for example, the sand could be extracted to be used again, the gravel, different things like this. And actually, we had a customer here in southern Finland who were implementing our FX10 and FX17 to sort those materials. Basically, you could see a conveyor belt where our camera are capturing the data and some robots are touching, or let's say, catching the different type of material to throw it away in different bins depending on what they are. So here again, thanks for the technology to be automated, where actually human will not be able to perform here in a reliable way, in an easy way as well. All right, all those applications, the one I was talking about, they require many things. It requires to have the camera, it requires to have illumination, but it requires as well to have the capability of transcript the spectra obtained with the camera into classes. And here, Specim understood that to make the hyperspectral imaging more easy, we decided to launch about a year ago SpecimONE. SpecimONE, it is a platform for sorting, but also for other applications, but especially for sorting, because basically it can classify different types of material based on their spectral signature offline, but it can be done online as well, because as you can see here on this slide, you can see that SpecimONE is actually a package. It is a platform, so it works with the camera, FX10, FX17, and also FX50, and with the cube, which is actually based on a GPU for real-time sorting. And there is also Specim inside, which is a software to build the model. So then, once you have built a model with inside, you can then load it again into the cube so that you can have real-time data processing. So basically, now you have the possibility not to get spectra out of the camera, not only, but you can get classes. What spectrum corresponds to which class? You don't need basically to do any coding to understand the chemometrics or to interpret the spectra. This is done in depth here with the software and with the machine, with a nice graphical user interface, which makes things really easy. Also, because we understood that the more further we go into the integration of the technology into the industrial environment, the faster the integration for you in your environment it is. So here, it's really a shorter time as well to go to the market because already part of the work is done. It is also a flexible technology which allows an unlimited amount of application. And here, within this platform, you have the possibility to load many applications at the same time, many runtime, you could put it that way, dedicated to different types of sorting application. And then you can just select the one which is the most appropriate depending on the flow, on the stream that you are having on your belt. And it is also compatible with a major industrial machine vision standard, so that actually the integration of this system into your machine is actually as straightforward as possible. Enough talking. So now I would like to show you something. I'm going to make you a quick demonstration of our SpecimONE, how it can be used with the Insight and also the real-time application. Welcome here actually for the demo. And here first I will go through everything we have in here. So you can see I'm sitting just next to the demo system. So first you can see here we have the FX17, a camera link version, which is then connected to the cube, which is here. It's actually connected here. The cube is here, to acquire the data, to communicate with the camera, and also to run the application in real time. So you can get as an output from here, from the Ethernet cable, which are the classes of what the camera is actually seeing. This Ethernet cable is also used to be connected, to the computer here, to collect the data, but also to load the model. And then here we have the spectral train, which is here to mimic like a conveyor belt on which we have different type of material. So we have a bit of wool, which is here. We have samples made of cotton, which are here as well. And the last one made of polyester. And the last cards, actually, we have a mixture of everything. So this is the system that I'm going to show or to use. This is the one we have. And then here we have my laptop with the software. I invite you to have a look actually to the software now. So here basically this is a software. This is a software, so we are able to communicate with the cube. So this is a web user interface so that the laptop is connected with the cube. And you see by typing here the IP address of the cube, there is a possibility like this to communicate with it. You can adjust some parameter to acquire the data. So for example, here you can see that I'm working at about 600 frames per second with an exposure time of only 1 millisecond. And because what I'm going to sort, remember, some wool, some cotton, and also some polyester here, the samples are not that small, and the spectral resolution doesn't need to be that high. So that's why here you can also adjust the spectral and spatial binding configuration. You can acquire the data here, and once the data have been acquired, it's possible to get them like this in our software, Insight, which is a software which is used to build the model. You can just open the data set like this. You can recognize here the spectral train. And again, for each of the pixels, you have the possibility like this to get the spectrum. So here, for instance, you can see the spectrum at a single point of some cotton. Here, if I move further away, you have the spectrum which is of the wool, and then finally you have the one of polyester, which is just here. Be aware the spectra, they may look a bit rough because here I use the spectral binning time 2, meaning the spectral resolution is not the highest anymore. But as you can see, for our application, for the purpose here, this is the best. So when you make a model, you can just take the data set and take it here as a training. And here you can see I have made a lot of selection a bit everywhere on the train. So there are some which are dedicated, for example, to the locomotive, which are based on the track. So here you could see I made a selection for this part of the locomotive. So I made selection for the track, 2 on the locomotive, for the carts, because it could be made of different type of material as well, and also for the material. So 1 training selection for the sample made of cotton, 2 for those made of the sample made of wool. We could see the second one here as well, and 1 for the samples made of polyester. Notice that here actually it's not only 3 classes which are sorted, but it's a lot of them, because remember, this is not as if you have a conveyor belt which is made of single material. Here we have the table, we have the train made of different type of material, we also have the track and everything. But once you have defined correctly every classes with relevant training selection, you have the possibility like this to extract the spectra, so you can see how they do look like. But then remember, with this software, there is a possibility also to optimize your sorting system. And the way to do it is, for example, to select the bands only those which are interesting. We call that like spectral region of interest. And here, basically, you can see the model we are building is actually only taking those bands between 1062, it could be a bit smaller, and about 1690 nanometers. Why is that? It's because then here we can really take the peak at the far end of the spectrum here to sort the polyester, which is going to be here in pink. For the wool and the cotton, the spectral differences is mostly here and here. So again, that's why it's important to have the full spectral range, but it doesn't matter if you actually record everything that you have before. So once you can make this selection here in the software, it is in the model. Once it is in the model, it can then be transferred into the cube, and this will be set just automatically. When you have less band, it means you have less data to be processed. It is then easier for the computing engine, but also the camera can be faster because then less data need to be read. Once you have made your model like this, you can just try it and see about the sorting performance. So now we apply the model, and we can see that in the first cart we had mostly cotton, which makes sense. In the second one, we had mostly wool. That was also making sense. In the third one, we had only the polyester. And finally here, we had a mixture. So if I go back to the data set, we can see that the sorting is actually pretty good. And indeed, the cart, the track, and also the table, they are sorted in black as we wanted to do it. You have the possibility to make it with different colors as well. You can just choose in this way that everything which is not the fabric will be black, and then the classes will be basically with different colors, with a different type of materials. One thing I would like to highlight as well, in order to optimize the way to sort your things, your samples, you may apply some pre-processing. And here, again, the sorting software, the inside of Specim, include different tools for pre-processing, and here you could see the list. Of course, this is a list which may move over the time. There will be more and more, but at the current version, those are the ones. And here, to sort properly those samples from each other, a service key golay with the following parameter is actually rather optimal. Once you have made your model, you can then publish it as an application, which then go here. And this can then be sorted, loaded into the cube. Then we go back to the web UI. Then we can choose which type of application will be run. Here, fabric sorting for the webinar. This is the one which is selected. I can select here to see the application as an output and not the camera detector anymore. If we start the train, then we will see the sample passing underneath with a real-time sorting like this. So the train is coming again. And the samples are sorted in real time. This is basically the output of the cube, RGB colors, depending like this on the materials that you have chosen. That was a demonstration. So now we are ready to go back to the Q&A and actually to the end of the presentation. So here you have the demo. I hope it was interesting for you. And now here is a summary of how it happened. So here you can see on the bottom how things are connected to each other. So basically the camera is connected to the cube that we have over there, as that you have seen over there. Then it can capture some data. Once the data have been captured, it's possible to load them into the inside. Once you have inside which is there and have the data, you have the possibility to build a model. Once the model has been built, it has been converted into an application, which is then loaded in the cube. Once the application is loaded in the cube, it actually translates or interprets the spectra of the camera into classes. And here, the output of the cube is in the GigiVision standard. And the GigiVision standard can then be an input. Basically, the output of the cube is then an input in your sorting machine. And then, because it's GigiVision standard, basically it's compatible with most of those industrial ecosystem, to build your sorters. So it's compatible with Halcon, Beckhoff, LabVIEW, everything basically which has a GigiVision standard compatibility. Also, you have the possibility to use our UDP protocol. And then based on that, you can then trigger as well some PLCs. Then how to build a successful hyperspectral imaging project. So basically, the first step could be just to make a feasibility study. Basically, you don't know if the application can be resolved or solved with hyperspectral imaging. So here, please contact our sales team or application team, and they will be happy to tell you all the details in order that a feasibility study can be done. Once the feasibility study is done and the application seems to be doable, it makes sense to make an on-site demonstration. So then there is a possibility as well to rent some of our camera, and also we can also make like online demonstration. But really you can have this type of rental services for evaluating the technology. Once you have done that, when you start to make your first system installation, so for example, SpecimONE system has been installed on site for prototype, you have the possibility to test different type of application and to check which type of capability are offered, which discover some different type of application. Then, of course, there is also the training and the support. Our online community is here to support you with a step-by-step hands-on tutorial, and also the possibility to have like this external consultancy and kind of training and help for you if you encounter an issue. And finally, once you are fully successful with your integration, then it's time for you to get your money back somehow, like to get your return of investment. You have been investing in hyperspectral imaging systems, so then there is a possibility for you finally to make the money. All right, so now, if you want to contact us, please feel free. There is go to specim.com. So here you can really contact us. Our application team or our sales team will be happy to answer you, either to make a feasibility study, to discuss with you about it, to arrange a demo, to make for a quote. Yes, please, we are here for that. Do not hesitate, specim.com. Now we go for the Q&A. So I hope you liked actually the presentation and also the demonstration. So now me and Jörg, we are going to go through the question and answer, basically the question, and then we're going to try to answer our best. Jörg, can you confirm you are back online?
Yes, I'm online again.
Perfect. So that's good. So please, if you have more questions, please ask. We will go through each of them. And yeah, so we will start. So the first question was about contamination, basically, of tomato sauce or sauce. I think just a sauce, yeah, in a sauce on a bottle. So our understanding, my understanding is like basically you have a bottle which is filled with a sauce in there, and then you want to detect if you have some which is around. So I think that's the way I understand the application. I would say that here, the hyperspectral camera will be able to help you to identify if you have something outside of the bottle, if The container, meaning here, the bottle is having a spectral signature. So for example, you can imagine you have the tomato sauce seen through the glass. Does it have a different spectral signature as the sauce when it is like, meaning without the glass? So you need to consider, does the glass then has a spectral signature? In some cases, I would say it doesn't. In some cases, it does. So here I cannot answer like this perfectly, like yes, it works or no, it doesn't. It needs to be seen like if the glass is having a spectral signature or not. Okay, then sorry, I need to get closer to see the question. Do you need to learn the Specim cube with the material, or do you have already a database of material with a dedication spectra for this material? No, at Specim, we do not provide like spectral library. Of course, we have been making some feasibility studies. We know some of the material. And for example, if you go to our website, there is a blog. And on the blog, you can see, for example, we have been showing there the spectral signature, for example, of different type of fabrics. We also have the spectral signature of different type of plastics, but we do not provide those. So basically, you need to create your own spectral library with the sample you acquire. The next question, maybe Jörg, do you want to answer? Like, how do you
question
locate?
from Mark.
Yes.
How to locate products on the conveyor belt? Yes, the cube has encoder input, and so you can synchronize with the speed of the conveyor belt, and then you are able to pick or blow out the products. That's easy.
Okay, thank you. Then the next question is, thank you for the nice demo. By the way, I will not give the name of the people actually sending the question because it's kind of confidential in that respect. I know you cannot see.
Yes, I'm sorry.
The question, but I can say the first name. The first name is okay. How is the illumination setup? No, you did not miss anything. I actually did not speak that much about it. And here you are raising a very important aspect of hyperspectral imaging, the illumination. So when we do hyperspectral imaging, when we use a camera, basically, we measure what is the reflected light compared to the incoming one. If you are in the world of reflectance, if it is transmittance, well, it is a transmitted light. But anyway, so you need to have a light which is continuous over the spectral range. If you use a light which is not continuous, which is having some peaks, then you will not be able to measure the reflectance between those peaks. So basically, your application needs to be on spectral bands which are on those peaks. Typically, the illumination which is available for hyperspectral imaging, it is halogen. That's the one which is used the most for recycling. But not only, you could use like hyperspectral LEDs, for example. I will not give here any name of supplier, but there are many of those available for different spectral range. We know that supercontinuum laser, they are also available. They're a bit more pricey, but they could be really, really bright as well. Yeah, those are the source of illumination which is typically used. And here in the setups that I was using with the spectral train, we had 2 bars of halogen at about 45 degrees, and the camera looking in between. So you are not really affected by the specular reflection, but you are more looking at the diffuse signal. Can you also detect bio-waste with different bad waste? Jörg, do you want to handle that one?
Yes, a very popular application actually, and for public waste, or for collecting public bio-waste, there are applications to detect, for example, plastic in the bio-waste can, and so this is a very popular application to detect plastic in bio-waste, for example.
Yeah, the thing is that bio-waste, they don't have the same spectral signature, for instance, as plastics. Plastic, you have really clear like polymer related spectral feature, whereas the bio-waste is different. You have more like something which is having moisture and things like this. So this is not exactly the same spectral signature. So those can be actually nicely separated from each other. I need to check, there was a question. The maximum capture speed. The maximum capture speed here, it depends on the camera. It depends on many things, actually. For the camera, first of all, do you use the FX10, the FX17, or the FX15? They don't have the maximum frame rate each other. Then what matters as well, it is your application. Because with your application, with the FX feed, with the FX camera in general, I was starting to say the FX50, but no, all the FX camera, you have the possibility to reduce the spectral range that you are looking at. So for example, for the FX17, the full spectral range is between 900 and 1700 nanometers. But if your application doesn't require the full spectral range, but you can reduce it to something smaller, the camera can be even faster. And if you read less bands, it means the processing is also easier. But as a rule of thumb, we have customers using our camera over conveyor belt, which is about 1 meter or 2 meter wide, and it can be up to 1 or 2 meters per second, depending on the resolution which is needed. So here, if you want to know the frame rate achievable with the FX camera, I will encourage you actually to go to read our data sheet, which is on our website. But yeah, just to give you an idea, it's about a big belt like this for like waste recycling, about 1 to 2 meters per second. This is what our customer can achieve. Conveyor belt to separate various, sometimes pretty dirty plastics. Can Specim camera analyze contaminated plastics? Jörg, what do you understand by contaminated plastics?
There's a wide variety of contaminations. And yes, you will see the dirt. And as you already know, I'm sure when the plastic is very contaminated, you won't see the plastic anymore. And because we don't do X-ray.
We need to remind people that actually hyperspectral imaging is a surface measurement method, especially like this for waste recycling. And if you have a lot of dirt, well, basically the camera cannot necessarily see through the dirt. So that's one thing. Yeah.
Yes.
As you said. What are the possibilities to identify metal in electronic waste, which is densely assembled in small portion of area? The metal, that's a little bit tricky. We had customers actually trying to separate the metals with hyperspectral technology. The issue is like metals, basically, you don't really have molecules. You just have few atoms next to each other. It's not really like molecules. So it means that there is no proper absorption peaks or things like this. One could separate them, for example, based on their colors, because different type of metals, they could have different type of colors. But I have to admit that hyperspectral imaging is maybe not the best technology to separate the metals. Here you should use maybe more like magnetic induced field or related technology to do these kind of things. But as I said, if you want to correlate the color with the metal, you can do it with a hyperspectral camera. So this is what I can say here. What are the possibilities to identify metal in electronic waste? I think that's the same question. I had FX17 for 2 weeks to try it, and I really liked it. Thank you. Could you please a little, where can I read more about the output to PLC of SpecimONE? It is nice that we have this nice color picture you showed. I am really interested how we can get to the automation system. Okay, Jörg, do you want to speak here? You can start. I can make more comments then.
Actually, we have, for example, communication with backhoff interfaces. And so there's a nice interface already. And SpecimONE is open, or the cube is open to other I/O interfaces. So there's a communication protocol needed, and otherwise, please call us, and then we can go into detail.
Yeah, what I can add as well is like, the output of the cube, it is one of the protocol as an output, it is GigiVision. So basically, if you have a system which is compatible with the GigiVision standard, basically you can just get the output of the cube, and then you can have it within your system. We have been working, and our customers have been working with systems, for example, provided by backhoff, as you mentioned, Jörg. They have a software called TwinCat, and the interfacing between TwinCat and the output of our SpecimONE is really straightforward. There is also Halcon, where we have good compatibility, sorry, like this. I don't know, another one with DV compatibility is also like LabVIEW. There are some other ones, but as a rule of thumb, if you have DV compatibility, it's straightforward. We also have our UDP protocol, and here, as you were saying, you just contact us, and then we will give you the protocol looking like a manual. So then you will have the possibility like this to interface pretty easily with the hardware.
Yes, please.
Then the next question.
Liquid in a bottle.
What do you say? Liquid in the bottle. Okay, suppose that we want to see liquid inside a non-transparent bottle. What should the bottle be made? A non-transparent bottle. How thick should it be? We want to see liquid inside a non-transparent bottle. Okay, so non-transparent, you mean, I understand, to the human eye. So for example, it could be with a color, but it doesn't mean, because you know the color is only for the visible, it doesn't mean that for the infrared it is not actually transparent. So this is actually quite interesting. Could it be like completely black? So here I cannot answer 100% the question depending on the thickness. It depends what we mean by transparent and non-transparent in the visible, in the non-visible.
It shouldn't be made of metal.
Yes, it could be made of metal. It could be simply, you know, with a kind of aluminum layer which is inside. So here it's hard to say. But if you have something which is 100% opaque, well, you cannot see through basically. So it needs to be a bit more defined here to give like a proper answer. Or Jörg, do you have anything to add?
For example, opaque glass, it works.
Yeah.
And usually plastic from the supermarket, plastic shouldn't be black. And we have to check it.
Yeah.
Please, when you can, send us an image or a bottle, and then we can prove it. And it depends on the liquid too.
Yeah, then we can discuss, we can check together. Then the next question, is it possible to develop your own software for this camera? In Python, for example, how this camera system saves the data? Is it sequence of small MV spectral file? Okay. The camera itself, we can provide with the SDK, the software development kit. And the SDK, it has a C++ interface. Having said that, we also have a wrapper for Python. So basically, you will have the possibility to create your own acquisition software with the camera within Python. That was the first question. The second one, how this camera system saves the data. So then, if you use our acquisition software, yes, the data are saved in the NV data type. I think it's data type number 12 with unsigned integers, with BIL interleaves. So basically, with our acquisition software, you make one file, smaller, bigger, depends how long you record, and it is an NV file. If you make your own acquisition software, well, then basically you can choose how you want to save the data. It's up to you. So the next question, does the Specim MQ will have sphere type? Aha, that's a little bit of the out of this webinar. That's good. That's a good question. Specim IQ, just to tell everyone what it is, because I'm not sure if you are familiar with it. It is like our portable VNIR camera, which is between 400 and 1,000 nanometers, and it looks like you know, like a normal camera when you go on holidays. And this is really practical when you need to go on the field or when you go to the museum, for example. Then the question is like, are we going to have the next version, let's say that way, which is between 900 and 1,700 nanometers? Sphere could be also up to 2,500 nanometers or not. Well, here I must say I cannot give too much detail because this is part somehow of revealing our roadmap. And I know that we have some competitors here listening to us. By the way, hello to you. I'm happy to have you here. Absolutely no problem with that. Just like, please understand that we cannot reveal really like confidentiality about our roadmap. What I can say is this is something we consider. So I don't want to tell more than that. How to buy demo kit? Jörg, I think that's for you.
Yes, one of the first slides of you. We have distributors worldwide. We have offices worldwide. Please contact them. They are on the website, and just contact them, please.
Do you want to take the next one as well? How often do you need to do the calibration? I mean, I think it refers to the white and the dark reference. Do you want to handle that one as well?
It depends on the sensitivity of your application. For example, for seal inspection, we know that they have to calibrate once per week. But when you have critical applications, for example, sorting PVC and PET, then sometimes it's necessary that you calibrate each day.
Yes, and it depends also if you have a camera which is in a stabilized environment. For example, I think about the FX50, you need to have it in a temperature stabilized casing so that you don't need to acquire too often as well the dark reference. For the white reference, it depends as well how you have cased your illumination for your system. So because you know the white reference mostly measure actually the light, the incoming light. So if it is proof to the ambient light or not, for this kind of thing. So it depends, as Jörg said, on how demanding is your application. If you want to solve two things which are really far away, spectrally speaking, from each other, well, that's pretty easy. But if they are close, that's more tricky, as you mentioned for the PET and the PVC. But then if you have all those things, as I say, like the environment, the robustness, also mechanically speaking, that do the thing. And finally, by the way, when you make a model, some models, they can be robust or not robust. It depends which kind of pre-processing you are using as well, which can actually compensate some of the deviation due to external factors. So it depends on a lot of things, but sometimes it's once a week. We have customers, sometimes it takes a white reference once a month. So it depends on the application.
Yes.
Okay, then can you explain a little bit better the classification procedure via training? Thanks. Okay, so then you refer a bit more to inside here when I was making the demo. So basically what you do when you want to make a model, you need to teach what is what. So you take some data, you acquire some data, and from there you teach what is what. The selection you are making, they have to be as representative of the sample you will get in your stream. So for example, if you get to sort plastics, and for the same material, you may have different level of dirt, as we were discussing, for example, or if you will have like kind of contaminant, you need to teach those, because if you do not teach those, then the system will not really understand what's going on. So you need to have like a training sample, a training set, which is as representative of what you get. And then based on that, you can train, you can teach the system what is what. You do not need necessarily to use as well data you acquire. You can use spectral library, but the issue with spectral library is that they do not necessarily have the same spectral resolution of the camera. It could be better, it could be worse, but anyway, it may not match perfectly well. So I'm used to say the training needs to be done first with the same type of instruments that you are going to use afterwards in the sorting machine. And for R&D purpose, you can do the thing in the lab, but as soon as you want to work with the real machinery, I would say the training, the acquisition of the training data set needs to be done with similar condition as when the model will be used. So I hope I answered your question. Then the next question. Following the contamination question or even wet holes versus dry holes, I mean, you have the clean or dry your garbage before trying the model, the spectrum. Okay, so how practical it is? Does it work in real factories? Do you want to handle here, Jörg?
It depends on, for example, when we have a lot of humidity in the product, we work, for example, with the camera FX10, and then it's much easier to differentiate between wet and dry things or wet dirt. And so it depends on the application and we have to talk about it.
Well, and in real factories, we have seen quite often that you have the washing process and then you have the drying process before to use a hyperspectral camera. We have seen that as well. Yeah. So how is your equipment at detecting thin plastic foil sticking the surface of food? Haha, this one is a difficult question actually. Because I have tried, for example, in jam. So imagine we had some jam, some marmalade, and we were putting some foil at the top of it. And here I have to say it didn't work. But then in another application, a customer was buying like some chicken fillet, and then they were putting some foil at the top of it, and then it worked better. So food, I will first define what is food. Depending on the food, it works or it doesn't. For the meat, it seems to work much better. For the jam, as I say, for the marmalade, it did not work. I don't know if Jörg, if you have some similar application.
Yes.
Like you did.
We have an industrial application made with robots, and for cheese block inspection, for example, very popular application. And when they unwrap the cheese, and they are wrapped in plastic foils, and these are blocks like this size, and then sometimes there sticks a rest of plastic on the cheese blocks, and that is detected, for example, with our spectral cameras. And it's an industrial.
Yes. And that was the FX17, if I recall well, right?
It's FX17, yes.
Yeah. Okay, so
for robot use.
Yeah, and for the cheese it worked. Yeah, actually, let's speak a little bit longer about it because it was a nice application. So basically, you had like a robotic arm, the FX camera mounted on it, and then you had the illumination side of it following basically where the robot was going. And yeah, that was pretty nice. Yeah.
Works well.
Yeah.
It depends in this case again.
I want to pose a question about the training for the set. What happens if a bad material in the flow is not detected before? Will it be recognized? There are actually two ways of detecting contaminants. So either you know when you are building your model every type of contaminant you can get. So basically here you can teach in your model everything which is contaminant. So for example, I have the meat, which is here, and that's one class. Then I have contaminant A, contaminant B, contaminant C, which are plastic, wood, whatever. And then I can teach what are those. Then it's easy. I define a class for each of them, and then it could be identified that way. Then you have the second approach. The second approach is like, this is the meat, and I teach a system, this is the good things. But everything we deviate too much, spectrally speaking, from the meat, actually is not meat anymore, but is a contaminant. It doesn't require the same way of doing the training. And here it just requires just set a tolerance threshold. So everything which is close enough to be the meat, then it is the meat. Everything which is too far from being the meat, then it's a contaminant. It's not the same in terms of training. And by the way, with Insight and SpecimONE, you have the possibility of making both approaches. So here is the question, if I understand it well, if a bad material in the flow is not detected before, meaning that you were not able to detect it before to make the training, how does it work? I hope I answer the question. Yeah, that's my understanding of the question. Does your spectrograph sensitive to input light polarization? Does hyperspectral polarimetry could be used with metal? Okay. So first of all, the spectrograph itself that we are using in the camera, we have about 2% sensitivity to the polarization, not more than that. So we have a little bit of sensitivity, but not much. And then indeed, there is a possibility in the front objective that we provide, for example, with the FX10, the FX17, there is a thread that you can mount here, a filter, and some of our customers are actually using polarizer in front of it. They use it for different applications. They use it to get rid, for example, of specular reflection, and I think this is what you mentioned here, for example, with the metal. They use it as well for geological application, because for minerals, depending how they're oriented within your samples, then you have different type of signals. So yeah, you have the possibility to do these kind of things. What is the next question? Can you give more information on laser hyperspectral illumination wavelength range available? Do you know something about it, Jörg, or shall I go on with?
No, I have no idea. And the problem is always you have a nearly small laser line, and it makes it difficult to hit the laser line when it is not spread.
Okay, so then I will speak a little bit about it. Then I was testing a laser. I'm not here to make like well, actually, I can say which was the manufacturer. It was NKT, sorry. And they are making a supercontinuum laser. And for example, I know that lasers, they have different spectral range. So you can have laser between 400 and 1,000 nanometers. So one I tested, it was between 450, I think that was the lower end, like I recall from behind my head, and the maximum was 2,350 nanometers. Basically, it was pretty broad. Then normally those lasers are a point, they just have like a point laser. But then if you put some optics in front of it, so for example, the power lens, you have the possibility to obtain like a line. So this is actually what we got, and we tried. And here I have to say you get really a continuous signal of the full spectral range. And I remember when I was discussing with a person from NKT, he told us that the main application where they sell those, it is mostly for the almond, for the separation of the almond and the shells. So that's what they say. So yes, so you have laser, you have different like spectral range available. Those are pretty bright, but with the laser, you have to be careful of one thing, the safety, because those are class 4 laser typically, so you need to handle them with care. But that's a technology which is available.
Question, can the FX50 identify black plastics from other colored plastics? Actually, Mathieu, I'm not sure whether carbon has a special signature, and I would say actually it's not possible to identify black plastic from red plastic when it's the same type.
Yes, I agree. I agree with you. So basically, when you have two samples made, for example, of ABS, if they are red or if they are like black, it doesn't make the difference. So basically, it will be just sorted as ABS. So the thing is that the FX50 can be used to sort plastic from each other regardless the color, but you cannot then sort based on their color. Okay, so then I will take the next one. In textile sorting, can we, with the FX17, classify subgroup of each type of textiles, for example, separate cotton from linen or silk from wool? All right, so actually here, I invite you to check on our website. There is a blog, and in there we are making some publication of some time of like application note and study. And we made one especially about fabric sortings, and there we are measuring, or like you can see, like the spectral signature of cotton, linen. You can find the one of the wool, different type of wool. Like there was some made of provided by alpaca. There was a merino. There were some different ones, and I have to say that for some type it is difficult. For example, the linen from the cotton, to the best of my memory, it is a little bit tricky. But you were asking more specifically the silk from the wool. This is more different. So yes, in some cases you can separate with a different type of like subgroups, as you say, but it's not always the case. Okay, so Jörg, please go ahead.
Oh, the third one. What are the software to acquire hyperspectral imaging or image from Specim FX17 to do our classification algorithm? Two ways. You have the chance to use a GigE or a camera link version of the FX17, and the GigE version is GeniCam compliant, so you just can acquire the image with a GeniCam based SDK or with the Lumo SDK from Specim itself. Then the other version would be to use a frame grabber with the FX17 camera link that has the advantage that you have higher frame rates. And so you use the SDK from the grabber, and then you can acquire spectral data from the FX17.
All right. So then I will go to the next one. So with the FX50, what is the smallest working size, length, time, width for plastic moving on a conveyor belt? All right, so here it's more like about the spatial resolution, basically, of what you can do with the FX50. Well, first of all, it depends on the size of the belt. If you have a belt which is wider or smaller, then you can have like smaller samples, because you have to think about it like the FX50, it's a line scan device. So it's like, by the way, all our cameras are line scan device. And each pixels along the lines, and they can measure different spectral information. And for the FX50, you have 640 spatial pixels per line. So basically, you take the width of your belt and you divide by 640, and that gives you the pixel size. Having said that, it doesn't give you the smallest object you can separate. I'm used to say that you need to have at least 3 pixels. So like I would say it is 3 times the sampling size. Why is that? Because if it is only 2, you may have, if it is only twice, sorry, you may have the issue that you will never have, or really seldomly have, actually a pixel which is only the pure material, the pure sample only of what you want to measure, but you will have a mixture of the sample with the background. And to have a good sorting accuracy, you don't want to do that. So that's why I'm used to say you need to have an object which is at least 3 times bigger than the sampling size. And this is this direction, but you can apply it as well in the other direction. So this is what I'm used to recommend. Okay.
Next question. In which speed they can scan the materials? The scanning speed of the cameras depends on the field of view and the minimum object size. And so, for example, to give you an idea what's possible, when you have a field of view 200 millimeters and minimum object size can be 3 millimeters, then you can run the camera, for example, in FX17 with up to 2.5 kilohertz.
All right. Thank you. Then I will take the next question. In the Specim Cube, the first step is image correction. To perform this step, is it needed to have a given calibration pattern? If only a white reference should be given, does it need to be a white element of a specific material? I think by image correction, when you mention that, what you mean, it is actually normalization. And normalization, I must say, it's not the first step you should use only with the cube, but this is something you should use actually every time you are processing basically raw data. So the way to do that, the step of normalization, is just converting the raw data of the camera into reflectance. And the reflectance, it is basically the level of reflectance. So it is in percent for each wavelength, what is reflected compared to what is incoming. And the way to do that, you take your image or raw data, you remove the dark, because every camera, every sensor, they have a noise. So here you remove the dark and you divide by the white minus basically the dark. It's always better to use a white reference, which is white, meaning in a spectral point of view, meaning reflecting at 100% the light over the full spectral range between 400 and 1000 nanometers if you are using the FX10, between 900 and 1700 nanometers if you use the FX17, and so on and so on. But we understand that this type of material, it is the best you can use. It's a spectraclone, but that's also quite expensive in a way that it can get dirty, especially if you're in a recycling plant. So you want to have something which is washable, and that could be, or it, let's say it doesn't get dirty too easily, neither damage. So we have some partners, some customers are actually using different type of materials, type of ceramics. It's not ideal at 100%, but still it's good enough. So it needs to be something which is, in short, reflecting the white, the light, close to be, I will not say 100%, but as homogeneous as possible. It could be a gray reference as well. And then you can do the normalization. Thank you. Please, Jörg, you can go with the next one.
Construction, sand, absorption. I have not so much experience in construction waste.
Wait, I need to read the question first. What are the wavelength range of the camera? How do you discriminate building materials such as sand with no absorption band in the linear sphere versus MWIR bands? All right, so now it's more like about geological application almost. Well, we have customers. You saw the video, for example, here for the waste construction, and it's not sorting only sand. Basically, when we are talking about building material, we are talking about wood, we are talking about metals, we are talking about cement, we are talking about concrete, we are talking about a lot of different things. And what we have seen is that most of our customers in this business are actually using the FX10 along with the FX17, meaning that here it's a combination not only on one wavelength, but it could be several together. And actually, it's what you say here, VNIR sphere compared to MWIR. So our customers have been quite successful actually with this, with the Veneer sphere. And I think Veneer sphere, you mean between 400 and 1700 nanometers. With the MWIR, I don't have a lot of experience with the sand, I must say. It could be used as well for geological application. It could be tested, for example. But here as well, you need to think about rentability in terms of cost. And I think here FX10, FX17 for construction waste is actually faster to get your money back than with the FX50. Having said that, I think they manage pretty well with FX10, FX17 because you could see it that way. If the sand doesn't have any spectral response, the others actually have a spectral response. So that means that you could work in a bit like eliminating way. If it is not the others, then it could be sand. But I know it's not the best way to do. Okay,
So how clean?
Sorry.
Okay, next one.
Yeah, please go ahead.
How clean must samples be to properly capture? What is the effect of dirt, water, and other contaminants? Spectral imaging is a surface-based technology. So if you have too much dirt on an object, you won't see the object. Water covers a lot, for example, in the range from 900 to 1700 nanometers. There you have absorption at 1450 nanometers. Therefore, for example, when you check living fish for parasites on their skin, you never do it with a FX17, for example. There you do it with an FX10 because you don't see the water in this case. And so keep the products or your objects as clean as possible and dry as possible.
Okay, thank you. Then I will take the next question. How much for SpecimONE GPU modules? Well, that's a price question. I'm sure a lot of people would like to know, but I'm not going to say it here. We are not going to say it here because I know and we know that we have some of our competitors actually looking at this webinar. They are welcome. I'm happy to have you here. I don't have any problem with that, but it's understandable that I'm not going to give our price like this just like at the middle of the place. So I will ask you to send an email to our sales team, and then they will answer to you and they will give you the price for the SpecimONE GPU modules. Okay, so Jörg, you can take the next one, please.
Yes, can different type of salts resolved using HSI? Mathieu, I never saw sorted salt. Did you?
Well, okay. Yes, about salt. I haven't sorted different type of salt, but I mean, could be tested. I just know that I have measured some type of salts, but I never tried to compare between each other if there are some differences. Could it be due, for example, if it is a salt which is like a rock salt, or it is like more like from the sea salt? I don't know. It needs to be tested. I really don't know. I will just answer to a question that we jumped over. What is a grabber? I think it's not gripper, but I guess it's grabber that you have shown in the first video. It means that it was with the SpecimONE, and it is a grabber that we have inside the module. And I'm not going to tell which one we have. It's like confidential information, which kind of material we have in there. Do you take the next one if it is possible
to use? Is it possible to use FX10 instead of FX17 for plastic?
Yeah, please go ahead.
Yes, it sometimes it could be possible and you can detect, but the signal is much better and reliable with the FX17. So it can be done with an FX10, but the recommendation is FX17 for reliable results.
Yeah, and I will add, if you go as well to our website on our blog, there is actually the spectral signature of the most common plastic, which is actually plotted there between 400 and 5.3 micrometers. So 400 nanometers, 5.3 micrometers. And you can see that there are some peaks for some plastic, as you said, Jörg, with the FX10, but those are really weak and hard to rely on.
Yes.
Do you have solution to measure the percentage of pure material, PEPP, when analyzing a composite material? Okay, so here it starts to be more like a quantitative data analysis. I must say that we haven't been exposed too much to those one. Most of the time when we have customer asking to measure sample and to make feasibility studies, those are pure material, either PE, either PP, either ABS. We have the PC ABS, but it's again a bit different. But if it is a composite material of PE and PP, I don't have a lot of experience. So I could imagine that the spectrum of the base plastic, let's say if it is PE, if you mix it with PP, I could imagine that the spectral shape is changing, but I don't know how much. So it's hard for me to give a precise answer here.
I would expect that there is a change,
Yes.
and it's an actual topic regarding regranulate, for example. And so you will see a difference between virgin material and regranulate, for example.
Yeah, but can we make quantitative analysis of that? Need to be tested.
Not really quantitative, but you see it.
Okay. Do you take the next one?
Yes. Does your hyperspectral can identify different materials like aluminum and the other metals? Yes, we had applications for metal sorting in the visible range and done with an FX10, and that works, but there is no molecule vibration at metals, and so the spectral fingerprint is not that good that you are able to sort metals with FX10 or FX17 and FX50, for example. There's the recommendation FX10.
Okay, thank you. So then, is it possible to separate construction waste while material is falling from the top, not directly lying on a conveyor belt? Well, yes, you can, but be aware that hyperspectral imaging is a surface measurement method. So that means that if you have material falling down, you will be able to see only what is exposed basically to the camera. So if you have something falling down in front of something else, you will not be able to see the something else. So that's the reason actually why we prefer to put the thing, I mean, not us, but our customers, they prefer to have a conveyor belt where you have the material which are separated from each other, and then you have the picker who can just grab and then throw away the things. You can sort them like this. But with the falling down, you may have the risk of having things hiding the other one, sample hiding the other one, and that's a bit of a risk.
Next, would any of the camera work if it is a dark environment?
That's a good question.
FX10, FX17, it depends on what is dark in when you have illumination from 700 to 1700 nanometers. For the eyes, it's dark, and the camera will see something. Usually FX10 works in the visible range from 400 to 1000 nanometers. There you will see the light, and otherwise you won't see a light. FX50 works with heat radiation. You won't see, and the range from 700 to 1700 nanometers isn't seen too, but for the camera it's visible.
One thing I would like to I would like to say a bit more here about working in a dark environment. You can consider the camera, for example, working the emission mode. So you may have a sample, for example, we're in a dark room and you want to see how it emits. Then it's dark around, but it is emission. it could be seen that way. So for example, I know like in the steel industry, if you want to measure the temperature of the stack of the material, then you are in dark environment, and you need to be in the dark environment so that actually you see only the emission of the hot steel. There are also thermal cameras. So for example, if I think it was a long wave infrared between 8 and 12 micrometers, those can be flown at night because actually you measure the emission from your samples again. So here actually it's a requirement. So I would say, yes, they can work in the dark, but again, it depends on your application. I can take the next one. We are using a Pleora adapter, camera link to Gigi. Okay. Trigger from a conveyor belt can be connected to a PC. Yes, we don't have any problem with that. Or to manage a trigger signal, we have to use camera link connection. Okay. So here it comes with the triggering of our cameras, basically. So there are two ways of doing it. With our camera, either it can be done via the power. So there is, like we have the connection with our camera, and it has multiple like cables in there, and two of them can be actually be used for the external triggering. It could be also used for strobing. So the camera can generate also a signal to trigger some other instruments. And the camera link cameras, they also have the possibility to be triggered via the camera link cable, via the grabber. So you have possibility to do that. And actually, we have many of our customers who needs to have perfect synchronization between position and the belt and when the camera is actually looking at something for ejection at the end. So they are using encoder, like sending TTL pulses to the camera for like external triggering. Do you want to take the next one?
What is the best conveyor belt material for plastic sorting with FX17? In this case, I would recommend a black conveyor belt because that isn't seen from the FX17. So you have a great background or a dark background, and you can differentiate between the other plastics very easy.
And I would add as well that the conveyor belt needs to be made of another material of what you want to sort. That's another thing.
Yes.
Yeah.
What is illumination type of FX50? Which bulb, for example, or the heater, Mathieu?
Yes, it is a heater. So basically, it looks like an electrical barbecue, like, it is a resistor, and it is heated up at about 650 Celsius. And this is what we use. So this is not a halogen, this is a heating element, and we have it at Specim, and it's just producing the light for the FX50. Yeah. Okay, so please, can you take the next one, Jörg?
Can a FX17 sort biodegradable plastic? I never had this. Did you have it?
I had. Yes,
okay.
I had. Yes, I had, and I must say that it seems to be doable. I don't have a lot of experience, but I have tried twice or three times, and it seems the spectral signature, was different from the other one. So it seems to be doable. Yeah. What is the maximum distance from the camera to the object to identify? You want to take it or I take it?
Take it, please.
Please. So basically, the camera can look at infinity. So then there is always a shortest working distance, and that usually depends on the front objective. So for some of our lens, it is 10 centimeters. For some others, it is 15. For some others, it is 30. So that's the shortest measurement distance. But then you can have an object located to infinity, and that actually doesn't matter. You just need to adjust the focus. So you are focused to the infinity. The only thing you have to keep in mind is that if you have the object which is further away, you have the pixel size which increase. So then basically the object you can detect, they get bigger as well. But that's the way it works. Congratulations for the presentation. The information has been clearly explained. Thank you very much. So thank you. I think we will conclude here. So Jörg, do you have any word to tell to our audience?
I would like to thank you very much. And these were interesting questions. And this time it's not tomato sauce. And it was really regarding our topics. And yes, thank you very much.
Yes, thank you. Thank you very much. And don't forget that if you have any question, please send us an email, either to me, either to Jörg at info@specim.com. We are happy to be with you, and I wish you really to have a nice day, a nice evening, a nice morning, depending where you are located. And okay, bye-bye. See you next time.
Thank you very much. Bye.